Hello everyone, my name is Mirjamilan Farabi and I am excited to present SENTIEBL, a fully automated framework I developed for the OpenAI GPT OSS 20B Red Teaming Challenge. The core idea behind SENTIEBL is to systematically uncover and analyze vulnerabilities in large language models, moving beyond manual ad hoc testing to a more rigorous, reproducible, and scalable approach. We are in the midst of an AI revolution, but our methods for ensuring AI safety are lagging, creating a critical safety gap. Manual red teaming is like trying to inspect a skyscraper with a magnifying glass. It just can't scale. This project's motivation was to bridge this gap. My objectives were clear: to fully automate the red teaming process, make it systematic, ensure the findings were reproducible and actionable, and deliver a turnkey solution that empowers the entire community. Well, SENTIEBL is my answer to this challenge. It's a complete end-to-end system that automates the entire red teaming lifecycle. At its core, SENTIEBL is built to be comprehensive, systematic, and safe. It uses a large curated library of prompts and patterns to test the model thoroughly, analyzes only the text the model produces, and generates actionable reports that make it easy to understand the model's security posture. Well, let's take a look at how SENTIEBL works. The architecture is a modular four-stage pipeline. It starts with initialization. The heart of the system is the audit loop, which systematically sends prompts to the model and analyzes the responses. If a response is flagged, the system generates a detailed finding. Finally, the reporting engine creates a full suite of analytical reports and visualization. Well, diving deeper, the pipeline starts with prompt injection using varied strategies to test the model under different conditions. The model's response is then passed to our analysis engine, which uses over 450 patterns to score it on severity and breadth. When a vulnerability is confirmed, SENTIEBL auto-generates a standardized finding, and at the end of the audit, compiles everything into insightful, easy to navigate reports. Well, this is the part one, prompt injection section, and report analysis and scoring diagram. And this is the automated findings and reporting diagram. Well, in experimental setup for this challenge, I ran a comprehensive set of experiments on the GPT OSS 20B model in a Kaggle environment. I designed a test matrix of 9 separate strands, combining each of the 3 parameterization methods with 3 different reasoning level, low, medium, and high, to get a complete picture of the model's behavior under different configurations. Well, as we can see in the quantitative overview, the results of these 9 runs were quite revealing. As you can see from this summary table, we saw attacks success rate between roughly 4% and 12%. The most significant finding was that increasing the model's reasoning effort consistently made it safer. But critically, no setting eliminated vulnerabilities entirely. The randomized parameter approach also proved to be slightly better at uncovering hidden issues. This is the total chart. And in visual analysis and insights, the visual dashboard shows that the certain categories like issues with the model's chain of thought and data exfiltration were common across all tests. This tells us that while we can reduce the quantity of vulnerabilities with settings like higher reasoning, the quality and potential impact of the remaining ones are still a major concern. These are all 9 tests, and this is the severity score ratio across all 9 tests, as we can see. And in the high impact section, from the hundreds of issues SENTIEBL uncovered, I selected the 5 most critical for submission. These aren't minor flaws. The system successfully elicited responses with a severity score of 10, including generating a command to wipe a hard drive, providing instruction for making an explosive device, and outlining detailed espionage tactics, highlighting the serious potential risks in these models. Well, in this section, I can say what are the remaining takeaways. First, giving the model more computational resources for reasoning does make it safer, which is a valuable insight. However, it's not a complete fix. A critical vulnerabilities can still slip through. And finally, this entire process underscored just how essential automation is. The sheer volume of tests required would be impossible for a human. Well, in this section, it's a tutorial section that I can tell you. I want to show you just how easily it is now to use SENTIEBL. There are just 3 steps. First, with Olama running, you install the package with a simple pip command. Second, you create a small Python script to import and configure the main audit function. Third, you run the script from your notebook, or if you use your desktop or laptop, you can use terminal, and SENTIEBL takes care of the rest. Once the run is complete, you will find a new directory with all the results. You will find raw JSON findings, charts, CSVs, and 2 key markdown files. The best place to start is by opening the detailed finding.md file, which contains the main dashboard with all the charts and finding card. This is the example of the finding card. Well, to ensure the full transparency and encourage further research, everything I have discussed today is publicly available. The complete source code of SENTIEBL is on GitHub, and then the packages is on PyPI for easy installation. All of my Kaggle notebooks, the complete datasets from every test run, and a detailed tutorial are public as well. In conclusion, SENTIEBL has proven to be a powerful tool for automated red teaming. It systematically identified severe vulnerabilities and provides a clear framework for reproducible AI safety research. Looking ahead, a plan to enhance SENTIEBL by integrating semantic analysis and developing a system of dynamic adaptive prompt generation. Well, thank you all for your time and attention. I hope this presentation has provided valuable insights into the SENTIEBL framework, and the importance of automated red teaming, I would now be happy to show the code in notebook that it has several files. Like you can see the config file where we can configure in this py file, and a complete directory py file sample I have added into this notebook. And you can also check from the GitHub repository. These are vulnerability patterns discovery, and we can check all the severity scores and key generation from there. Also, it also has the main py file where it shows everything and all the details are written here. So for tutorial purpose, you can check and run this for your automated generations. Thank you. That's all from me.